மேம் அந்த இதில் ஆடியோ டிரான்ஸ்மிட் ஆகிற மாதிரி தெரியலையே மேம். இல் ஓ நீங்கள் மியூட் பண்ணி வச்சுருக்கீங்களோ உங்கள் இதில் அங்கே கீழே? அதான் ஏன்னா நம்ம பிள்ளைங்க தெரியுதாங்க, ஆடியோ எதுவுமே வரலையா மேலே, அதான் கேட்டேன். சரி மேம், ஓகே. அதான் கேட்டேன். நம்ம வீடியோ கொஞ்சம் கரெக்ட் பண்ணி வைங்க மேம், வீடியோ கேமராவை. அது என்ன பிள்ளைங்களை வந்து ஃபோக்கஸ் பண்ணால் மேலே கொஞ்சம் ஃபோக்கஸ் பண்ணி லைட்டாக கொஞ்சம் டில்ட் மட்டும் கொஞ்சம் மாற்றி வைங்க, டில்ட் பண்ணுறதை மட்டும். ஓகே ஓகே. அந்த மேம் லைட்டாக தெரியுதாங்க, போயிட்டாங்க மேமு. இந்த இந்த மேம் தான் இருக்காங்க. ஓகே. இல்லாட்டி மேம் இந்த போடி ஒதுக்கி வச்சுருந்தேன் மேம், போடி ஒதுக்கி வச்சு டேபிளே வச்சு விட்ற வேண்டியதானே மேம். போடி எவ்வளோ ஹைட்டாக வச்சுக்கிட்டு, ஹைட்டாக இருக்கிறனால மேலே தெரியுது. இந்த பொடி ஒன்று தானே வச்சுருக்கீங்க ஒரு சின்ன ஸ்பீக்கிங் டேபிளில், அதுலேருந்து வேணா கீழே வச்சு பாருங்க, அதை எடுத்துட்டு கீழே வச்சு பாருங்க. பசங்க வந்து அந்த அந்த பொடி ஒதுக்கி வச்சிருங்க, பொடி ஒதுக்கி வச்சுட்டு நம்ம சிபி இருக்குல்ல, சிபி மேலே வச்சு டிரான்ஸ்லேட் பண்ணி பாருங்க, கரெக்டாக இருக்கும். அதில் வச்சு பாருங்க, பொடி நாட்டிடுங்க, ஸ்டேஜ் நாட்டிட்டு வேற எங்கேயா மூவ் பண்ணிட்டு இதை பண்ணி வச்சு பாருங்க. இப்போ இந்த பிள்ளைங்க தெரியுது. இப்போ அந்த பிள்ளைங்க தெரியுது. இப்போ இதை மறந்துடுச்சு. நம்ம கேர்ள்ஸ் ஸ்டூடெண்ட்ஸ் தெரியுதாங்க. ஓகே. இப்போ கரெக்ட் மேம், இப்படி வச்சு விட்ருங்க. ஓகே. இப்போ நீங்களும் பாருங்க, கரெக்டாக இருக்கும். அந்த பிள்ளைங்க உட்காந்துருக்க மாதிரி இருக்கும். ஏன்னா மேலும் ரொம்ப மேலே தெரிஞ்சிட்டு இருந்தது இது. இப்போ ஓகே மேம்.
To make our media more blissful, I honorably welcome our students and all students. With great pleasure in our hearts and smile in our face, we take pride to start this webinar. Once again, welcome you all. You can read the Bible and shoot back until you study it. It doesn't come alive for you and teach you the lasting lesson. Take time, study God's word, it will change you. So, I would like to call upon Ed Christina Sabin from Career Easy for Bible reading and prayer. I request all to kindly stand up for Bible reading. A reading from the book of Psalms, chapter 23, verses 1 to 4. The Lord is my shepherd, I shall not want. He makes me lie in green pastures. He leadeth me beside these still waters. He restored my soul. He leadeth me in the path of righteousness for his name's sake. Yeah, though I walk through the valley of the shadow of death, I will fear no evil, for thou art with me. Thy rod, thy staff, I comfort me. Prayer, please close your eyes for a few seconds. Let us lower your heads and put yourself in the holiness of God and the Father and the Son and the Holy Spirit. Dear Almighty God and ever-loving God, we glorify and thank you, name and shower you with such a blessing, and the presence continue to remind us for a faithful and guidance. May we humbly ask you to shower our speaker today of the greatest inspiration, so that he may share the most of his knowledge, his gift, and experience to respective in the manner. In the knowledge, experience, and put it into practice, we should make up today. Your infinite blessing would mean the success of the seminar. May we be living witness of your genuine love through the enactment of the knowledge acquired through the activity. We ask it in the name of Jesus Christ of name. Becoming challenges, look for the opportunities in every situation to learn and grow in wisdom. So, I kindly welcome our speaker, Dr. Lima Vincent, PhD, who completed her BE on National College of Engineering, Chennai, ME and PhD on College of Engineering, DB on Chennai. She has many roles of work experience such as lecturer, assistant professor, and associate professor. She is one of the authors for 11 publications that are published in SPI journals and 4 patents. Next, I would like to welcome our HOD ma'am and all staff and all of our students. Without any delay, we hand over this webinar to our teachers.
Good morning, Honorable present over here. Am I audible? Am I audible? Ma'am? Am I audible, ma'am?
WhatsApp we can able to hear, but not in the YouTube. Just wait.
Okay, okay, ma'am.
Yes.
Am I audible, ma'am?
Madam, just you speak, madam. Just we want to check.
Am I audible, ma'am? Hello?
கேக்குதா? கேக்குதா?
Am I audible, ma'am?
Madam, you are audible for in this Google connection, but we have connected in a seminar hall. In that presentation, we are not able to hear your voice.
Okay, okay.
Just a minute, Vijay, we are checking.
Okay, I'll wait here, ma'am. Okay.
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 இங்கிலீஷ்ல போகாது ஸ்பீக்கர் ஏதாவது பண்ணாங்க உங்களோட வாய்ஸ் அவங்க கேக்குமா? ஹலோ
Hello.
நான் பேசுறது கேக்குறீங்க?
Hello, ma'am.
மேம்
Am I audible?
not audible, madam. Still, we are not connecting the speaker to students.
Okay. No issues, ma'am.
Just a minute.
Okay, no issues, ma'am.
Madam, now it is audible, madam.
Okay. Am I audible?
Yes, ma'am.
Okay. Shall I start to present, ma'am?
Yes, ma'am.
Okay. Ma'am, PPT is visible or not?
Visible, madam.
Visible. Okay. Good morning, one and all present over here. I am Dr. Lima Nelson. Currently, I am working as an assistant professor in research department at Chitkara University Research and Innovation Network. First, I would like to thank my supervisor, my professor, Dr. Muhammad Ali sir, for providing this opportunity to me. And moreover, I would like to thank JP College of Engineering faculties and management, one and all present over there. Thank you so much. Now I will start my presentation, that is machine learning using Python. My agenda is introduction about machine learning techniques, then types of machine learning, data pre-processing techniques, model evaluation, and then real-world applications. First of all, you all would know what is artificial intelligence and what is human intelligence. You must know the difference between human intelligence as well as artificial intelligence. Human intelligence is nothing but we can judge the things easily. We have the decision-making property with us, right? So this is the difference between natural intelligence and artificial intelligence. Natural intelligence is nothing but human intelligence. Human intelligence will adjust to the new environments by using a combination of various cognitive processes. Cognitive process is nothing but sensation. If we touch a thing, then we have some sensation property, attention, then perception. But in artificial intelligence, machines imitate human behavior and perform human-like actions. Then human brain is, for natural intelligence, we have human brain, but in artificial intelligence, we have computer machines. Here in natural intelligence, brain is our memory. We will store our knowledge in our memory. But here in computing power and the ability to think while AI-powered machines, that is CPU. Then in natural language, natural intelligence, human intelligence is all about learning and understanding from different incidents and past experiences. So we will learn from the past experience. For example, a small baby, first initially it will touch the fire. At that time, initially he or she don't know whether it will harm his or her skin or not. So initially she don't know whether the fire is harmful for her skin. After touching the fire, she must know that it will harm his or her skin. So after that, from the experience, the kid will learn, if I touch the fire, then it will be harmful for my skin. Like that, that is natural intelligence. like that, the artificial intelligence also will learn from the past experience. Past experience is nothing but in terms of data. It will learn through the data. So, intelligence is the ability to acquire and apply knowledge. How the intelligence, for example, you are a BE student, so you will acquire the knowledge from your degree, right? 4 years through the degree, you will learn some knowledge. From the acquired knowledge, you will apply the knowledge to some projects. So, in your final year, you have projects. So, from the first year to 3.5 years, whatever you learned, you will apply that knowledge to your project. So that is intelligence. Human intelligence is the ability of humans to acquire and apply knowledge. So only two things are there: acquire knowledge and apply knowledge in human intelligence. Artificial intelligence also the science of making computers to do things with intelligence like humans. So we are preparing the machine in terms of what? Computers. We are making the machine to behave like a human being. AI incorporate human intelligence in machines. How we will incorporate the human intelligence in machines? Through the past experience. Past experience is nothing but data. I will show the data. See? Acquire knowledge. You are learning the knowledge throughout your graduation. After that, what you will do for your job, you will apply the knowledge. Sometimes you will become a machine learning expert, data scientist, or software engineer, whatever it is. What you will do in your job profile, you will do whatever acquire knowledge from your past 4 years. Then that only you will apply in your job profession, right? So then what is the interconnection between computer science, artificial intelligence, machine learning, pattern recognition, whatever it is? See, computer science is using technology to solve the world's problem. AI means artificial intelligence. Artificial intelligence is a branch of computer science. Then machine learning is a subset of artificial. Inside the artificial intelligence, machine learning is there, data mining is there, statistic is there, pattern recognition. What is machine learning? We are providing knowledge, learning knowledge to the computer. That is machine learning. Then data mining. Data mining is
Madam, are you changing your place?
Yes.
It is not changed. Only the first slide only shown here. It is visible.
I am changing the slides, ma'am. It is not visible.
Yes. It is now only it is changed.
Then I didn't put it into slideshow mode. Is this visible to you all, ma'am?
Yes. Is it Priyanka? Is it visible? Check.
Ma'am, once again, I will share my screen in the slideshow mode.
Okay, ma'am.
Now is this visible, ma'am?
Yes, ma'am, visible. Actually, you have to share your full screen, madam.
Yes, ma'am?
Share entire screen.
Internet is poor, ma'am.
No. Internet is okay. Now it is changed.
Okay, then I didn't put it into the slideshow mode, ma'am. As it is, I will change the slides. Okay.
Okay, ma'am.
Okay. Computer science is using technology to solve world's problem. AI is a branch of computer science. So artificial intelligence is a branch inside the computer science. Then machine learning is inside the artificial intelligence. What is actually machine learning is we are providing knowledge to the machines. Machine in terms of computers, right? So it is a combination of machine learning, data mining, statistics, pattern recognition. So artificial intelligence is a combination of all the other four: data mining, machine learning, pattern recognition, and statistics. But artificial intelligence is a branch of computer science. So artificial intelligence is the branch of computer science that aims in making computers behave like a humans. How it will behave like a humans? Through the training only it will behave like a human. Then it develops expert system for reasoning. So it is having human like judging capacity will be there. Then uses models built by machine learning and other logics to reason about the world with intelligent behavior. Then statistics. Already you all know what is statistics. It is like a mathematics. It will collect the data, analyze the data, presenting the data, and interpreting the data. So, what is the job nature of data scientist? Anybody know? Job nature of data scientist is data scientist initially will collect the data from the problem statement. For example, if I want to develop a clinical decision support system that whether a patient is having diabetes or not, I am a data scientist. So what I will do, first initially I know the problem. So what I will do, I will collect the data from the environment. Environment is that is related to medical domain. So I will collect the data, then I will analyze the data. Analyzing in terms of if any relationship between the features or not. I will analyze the data. From the data, I will create a formula. Formula means what is the relationship between each and every features with the output label. So first I will collect the data, then analyze the data. From the data and data analysis, I will retrieve a formula or model, whatever it is. So I'm interpreting the data. Then next class is data mining. Data mining is nothing but mine means extraction of data. See, explains patterns using statistics and other logics, discovers hidden knowledge in the data. That is, I am extracting the knowledge from the data. I will tell each and every module step by step with example. Now, this is the basic definition. Data mining is nothing but extract the information from the data. First, we have to know what is machine learning predicts with models, learn with always, machine learning, we will provide the knowledge in terms of data to the computers. Then based on the data, machine learning models will learn from the data and predict the output. So machine learning model learns with data without being explicitly programmed. It uses data mining and other learning techniques to build models. What is meant by data mining? Data mining is nothing but extraction of knowledge from the data. Then deep learning is a subset. Deep learning and machine learning are interrelated only. What is the difference between machine learning and deep learning is the extended version of machine learning. For example, artificial neural network is the supervised machine learning. It's a type of algorithm inside machine learning. So in machine learning, artificial neural network having only multiple, for example, 1 to 10 number of hidden layers. But in deep learning, 100 number of hidden layers will be there. Purpose of increasing hidden layers is to increase the prediction accuracy. So it is a complex logic structure similar to how a human would draw conclusions. So how the human will decide, will take decision making. Based on that only, the deep learning algorithm will run. So this is the example data set. What first we have to know what is data, next information, knowledge and wisdom. So from there we will learn what is data. Data means each and every value is data. Data does not have any information. Information means value. For example, 90. It does not convey any information, right? 90, 98. Just like a numeric value only. But information is processed data that refers to summarized, organized and analyzed. For example, Ram has got 90 marks in physics. So from this Ram has got 90. This is one information. But 90, simply if you say 90 means it does not provide any information. But Ram has got 90 marks means it will convey some information. That is, Ram got 90 marks in physics. Next, knowledge. Knowledge means is the collection of skills a person has acquired through the experience. Experience means what? Experience here, experience in terms of tabular column, that data. This data is collected from the academic performance of each and every student, right? So in this data, this physics, maths, English, social, name, these are all the input features. This is the problem solving is the output feature, right? So input features are name, physics, maths, English, and social. These 5 columns are input features. This problem solving is the output feature. I will explain each and everything. Knowledge means is the collection of skills a person has acquired through experience. If student has got greater than 90 and max greater than 90, then problem solving greater than 80. See, here if a student has got greater than 90 marks in physics and greater than 90 marks in maths, then the particular student has the problem solving capability more than 8. It will range from 0 to 10. The output label. See, this is output label. The problem solving column is the output label. These 5 columns are input features. This is the output feature or output label or class label. So you can say in 3 terms: output label, class label, or output feature. Right? So from this, we got the knowledge. If a student has got greater than 90 marks in physics and greater than 90 marks in maths, then the particular student having the problem solving capability more than 8. See, sometimes if a student having greater than 90 in English, 90 marks in English and 90 marks in social, then the particular student having knowledge in literature. So here they have given highest value for physics and problem solving capability. Literature they have given less than 5 only, right? So 0 to 5 they have given for problem solving, more than 5 to 10 they have given for problem solving capability. So from there we got the pattern. So we got that knowledge. That is the knowledge. Information. So you know what is data. Data is simply the numeric value. Each and every numeric value or this is data. Next, information. Information has some amount of values there. Ram has got 90 marks in physics. This is the information. Knowledge. What is the knowledge you acquired? If the student having more than 90 marks in physics and maths, then the particular student have the ability to solve problem more than 8. So they have scaled from 0 to 10. The output scales are scaled from 0 to 10. If a person having 0 to 5, then the student have the literature ability. If the student have more than 5 to 10, then the particular student have problem solving ability is there. So this is the knowledge we acquired from that data. Next, wisdom. This wisdom is based on the knowledge we will provide the decision making. So designing decision support system for testing the problem solving. So we have developed a decision making system based on this acquired knowledge. We have acquired this knowledge from this data, right? We can say this as a data or data set. So 5 input features, 1 output feature. These how many samples are there? Totally 3 samples. First sample, second sample, 3 samples are there, right? So this is the information or description about the data set. Next, learning. Learning is in human based computers. We will learn through past experience, like fire can harm the baby skin. Like that, we will learn from the past experience. But the existing computers, how it will work. For example, Python programming. The computer will work based on the programs only, the computer will work. So computer follow the instructions. So how we can provide the knowledge to the computer to make a machine learning model? We have to provide the experience. Experience is nothing but in terms of data or data set, right? So we can provide the knowledge to the machine to make a machine learning model. So the computer will learn from the past experience, then it will provide the prediction model, right? So see, this is the difference between traditional programming and machine learning programming. Keep this in mind, traditional programming is Python programming. So Python programming, what we will do? For example, we have to create a calculator. We need to create a calculator, right? For that, we will do addition, subtraction, multiplication, and division. Basic operations only my calculator will do. So initially what I will do, I will write a program for addition, right? So sum A comma B. For that, I will provide the data. Data means, for example, for A equal to 3, B equal to 5. Like that, I will write the program as well as I will provide the data. From the program and data, the computer will provide the output. Output is 5 plus 3 is 8. Like that, it will give. This is the traditional programming. Traditional programming refers to any manually created program that uses input data and runs on a computer to produce the output. So, in the traditional programming, we will provide the data as well as program, right, to the computer. But in machine learning, we will provide the data as well as past experience. Past experience means, see, data. These are all the input features. Input data as well as output also we will provide, right, for problem, for develop a program. So we will provide the input as well as output to the computer. Then the computer itself will develop a machine learning model to predict. For example, if you want to diagnose diabetes disease, so what you will do, you will provide the input features. For example, what blood glucose level, then age, pressure level. These are all the input feature. Then output is whether the patient is having diabetes or not. That is in form of 0 or 1. So you will provide only the inputs to the computer. Then it will provide the program. Program means machine learning model. So machine will learn by looking at the previous knowledge or past experiences. So we will provide only the inputs to the computer. The computer itself will provide the model. Machine learning, the algorithms automatically formulate the rules from the data. So data analyst, what the data analyst will do? Data analyst analyzes the data. From there, we will develop a rules. Rules means some formulas. We have identified some relationship between each and every feature with the output label, right? So which is very powerful. Next, there are 4 types of machine learning. One is supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning. So supervised learning is nothing but learning with class label. Input features as well as output features we have to give to the system to develop a model. See, this is the example, right? For develop a model, we will provide this input features as well as the corresponding target output also we will provide to the system to develop a machine learning model, right? It will work for 2 types of machine learning algorithms, that is regression and classification. I will tell the types later. Next, unsupervised learning is used for clustering. Then reinforcement learning learns based on the feedback from the environment. Then semi-supervised learning is the combination of supervised and unsupervised learning. So first we will look at what is supervised learning. Machine learning process which trains a computer to predict based on the historical output. Historical output is nothing but with the class label. This is the class label, yes or no, whether the patient is having diabetes or not. Here, problem solving capability is good or low, right? So yes or no, that is the output. If I give the input like this, it will provide the output like this. The machine learning model will provide the problem solving capability is good or low. So here, machine learning process which trains a computer to predict based on the historical output variable, which means class label. So it learns with the example. It uses historical data that both input and output variable. So this is very, very important. Supervised learning algorithm will learn with both input as well as output variable. Then the machine learning techniques can be used for classification and regression. Already we saw here classification or regression. Supervised learning algorithm will use for regression or classification. See, regression classification means output is having a defined labels. See, this is the example for classification. Defined means discrete, yes or no, good, low. This is the discrete value, yes or no, 0 or 1. These are all the discrete values. So these kind of, if the output variable having yes or no or 0 or 1 having discrete value, then we can use this classification. There are several classification algorithms, supervised classification algorithms are there, decision trees, support vector machine, and naive-Bayes algorithm. Right? These are all the classification. Then you can say it is a classification algorithm. If the output label is discrete values, then you can say it is a classification machine learning technique. Next, regression. The regression also a supervised machine learning technique, but the output is having continuous value. What is meant by continuous value? The values are in the continuous manner. That is 0 to 1 or 0 to 10. This is in the range of 0 to 10. So this is a continuous value. So there are 4 types of machine learning algorithm are there. First one is supervised, unsupervised, reinforced. Another one is semi-supervised, right? In supervised machine learning algorithm, there are 2 types of techniques are there. One is classification, another one is regression. When we will use classification algorithm, if the output variable is discrete value, then we can use that in a classification problem. If the output class label is in the continuous value, then we can use it in the regression, right? Regression means continuous values. There are several regression, linear regression, non-linear. Linear regression means if we can split it into yes or no, like that. We can linear regression and only 2 input features means we have to use linear regression. Non-linear means multi-dimensional input, we will use non-linear regression. Next one is unsupervised learning. Unsupervised learning means, see, this is the example for unsupervised learning. Unsupervised learning algorithm will learn without the output label. See, this problem solving column is not there. So we will provide the input like this. From the input, it will group the data based on different patterns. For example, here it will develop a pattern from 60 to 70, then 71 to 80, 81 to 90, 90 to 100. Like that, it will form a different groups, right? Based on different patterns, it will create a group. So unsupervised learning based on the input observation, not the output variable. So output unsupervised learning uses historical data set that has input variable. Then clustering, group data. So it is based on grouping. Clustering means grouping the data. Group data based on different patterns. Another one is association rule mining. From this data, we will develop the different association, find out some very useful relations between parameters of a large data set. So we will find some relation from the data set. That is based on if-then rules, also based on unsupervised learning, right? Next, semi-supervised learning. It is a combination of supervised as well as unsupervised learning. Used with data that have fewer labeled data. Labeled data means what? This is the labeled data. This is unlabeled data. Labeled data means which has output label. Unlabeled means it does not have the class label or output label or output features, right? So semi-supervised is a combination of supervised as well as unsupervised learning process. It is used with data that has fewer labeled and large portion of unlabeled records. I will show that. See, this is the labeled data. Fewer, but here I have written equal portion, but fewer labeled data and more unlabeled data. This is labeled data. See, problem solving output feature is there, but here output feature is not there, right? So it is based on, it is a combination of supervised as well as unsupervised learning process. It is used fewer labeled data and large portion of unlabeled data. Initially, it is used unsupervised technique. Unsupervised technique means what? This is unlabeled data, right? So we have initially we will apply the unsupervised learning. Unsupervised learning means clustering. It will group into different clusters. Based on that, we will provide the problem for output. For example, if a person having physics and maths greater than 90, already we will define the rule. Then it will become a one group. Like that, based on the grouping, we will provide the output, right? So initially, we will apply the unsupervised technique, predict the labels. Based on the unsupervised technique, we will predict the labels. Then feed these labels to supervised techniques, right? So initially, we will provide the input for what purpose we will provide? For clustering. First, we will cluster. From that cluster, we will get the output label. Then after labeling means now we will get the output label. Then we will do the supervised learning. This is the combination of semi-supervised as well as unsupervised learning technique. This technique is mostly applicable in case of image data sets where usually all images are not labeled. Sometimes some images does not having the output label. Label means what? I will show the image data. See, label means if I label this is cat, this is dog. This means label. If sometimes this data does not have label, means cat, I didn't provide to the machine. This is cat for training. We are providing these data to the machine learning model for training. At that time, I will give this is dog, but I didn't give this is cat. So in that time, this machine learning model will use unsupervised learning initially, then it will use the supervised learning. Initially, it will label this is cat using clustering algorithm. Next, it will use supervised learning for prediction purpose, whether it is dog or cat, right? So this is semi-supervised learning. Next one is reinforcement learning. Reinforcement learning is a feedback-based machine learning technique. Agents learn to behave in an environment by performing the actions and seeing the result of actions. For example, you have to think you are learning to ride a bicycle, right? Initially, what you will do, you will sit in a wrong position, then you will fall down. From the experience, in the next time you will learn that if I sit like this, then I will fall down, right? So from the experience, from the reward and punishment, you will learn. That is reinforcement learning. For good action, the agent gets positive feedback. If I sit in a correct position, then I won't fail. That is reward. If you sit in a wrong position, then you will fall down. Based on the experience, you will learn. That is reinforcement learning. So agents learn automatically using feedbacks without any labeled data. So in this reinforcement learning also does not have any labeled data. What is meant by labeled data? Labeled data is nothing but output class label. If the output class label is there, then that is labeled data. If the data set does not have the output class label is nothing but this is the output class label. If the data set does not have the class label, means that is unlabeled data. If the data set has the output class label, then it is a labeled data. So based on the positive awards and penalty, if agent will learn, means that is reinforcement learning. We will use this reinforcement learning in game playing, robotics, temporal difference, Q learning. These kind of algorithms will use in this reinforcement learning. Next one is, this is the important steps in machine learning. Important steps for developing a machine learning algorithm. Keep this in mind. First, you have to define the problem. Right. First, what is the first step? You have to define the problem. Second problem is data preparation. Third is you have to train the model. That is, develop the model. Then you have to test the model. Totally 4 steps are available to develop a machine learning model. First step is you have to define the problem. See, this is the problem. To predict the problem solving capability of a student based on their academic skills, right? This is the problem definition. First, you have to define the problem. What is the problem? From this data, you have to predict the problem solving capability of each and every student in the class, right? So this is your problem. Problem is problem solving. You have to predict the problem solving capability of a student. First, to define a problem, first you have to know the domain, then objective and task, data collection, data description. These 4 things you must know to define a problem. First, what is meant by domain? So this is based on which domain? Academic domain, right? This is academic domain. If you want to predict whether a patient is having diabetes or not, that is which domain? Medical domain. So several domains are available. Sometimes transport domain, banking domain. So first you have to identify the domain of a problem. Then objective and task. What is meant by objective? Objective is problem solving capability. So this is the objective of this problem, to find the problem solving capability of a student based on their academic score. So this problem solving capability is nothing but this is the objective. Next, you have to collect the data. For this problem, where you will collect the data? You will collect the data from schools. From the schools, students' report card, right? Progress report, you can collect these data sets. So each and every sample is the student detail. This is one student detail. This is another student detail. Totally here 4 student details are available. So you have to collect the data from the school, from the domain, because it is a domain specific. First you have to identify the domain. Then you have to find the objective. From the objective you have to split the task. Next, third point is data collection, where you will collect the data from the domain. Domain is academic. From the schools, you will collect the data. Then, important thing is data description. So, you have to describe the data. So, in this data set, how many input features are there? 5 input features. That is, name is one input feature, physics, maths, English, and social. Then, how many samples are there? 4. Each and every row is one sample. So you have to write the data set description. In how many input features, how many class label, how many samples. These are all the data set description. So define a problem. First you have to identify the domain. Then you have to find the objective. Objective is nothing but the problem. Then you have to collect the data. Then you have to write the data set description. Next important thing is data preparation. What is meant by data preparation? Data preparation means data pre-processing. When you collect the data means this data set. Keep this in mind. Data is nothing but this data set. Initially, when you collect the data set having some noisy or missing values are there. So you have to process the data for creating your model. If you have given the wrong data, means if the improper data, if you have given to the model creation, then your model will be given less accuracy. That's why initially you have to prepare the data. That is nothing but data pre-processing. First you have to define the problem. Next you have to process the data. Data pre-processing. Data preparation is nothing but data pre-processing. There are several steps are available. Here I have written only 3 steps. Initially data cleaning, data transformation, feature selection. In data cleaning, you have to identify and correct errors. See, this is the data set. They have, instead of 62, they have written 2 simples, unwanted simples. This is called noisy data. So we have to clean the data. We have to write the proper data instead of this noisy values. So for that, several algorithms are there to replace the correct value, right? If the data set missing or noisy values greater than 30%, 25% based on the model, the researchers will provide the limit or threshold. Based on that, the noisy value will remove or correct with the corrected data. Right? This is the data cleaning, handling missing values, outlier analysis. What is mean by outlier? First of all, we will see missing values. What is mean by missing values? Sometimes if this place the data is not available means that is missing values. How did you replace that? Based on several rules, we will replace the exact value in this data set, right? So that is nothing but handling missing values. Next one is outlier analysis. What is meant by outlier analysis? See, here they have written the marks between 0 to 100, right? Sometimes they have written 900. Instead of 100, they have written 900. So that is not in the range of 0 to 100. It is outside the range. That is called outlier, right? Outlier is nothing but the value does not belongs to the particular range. Here the range is between 0 to 100. Everyone knows that the marks between 0 to 100, but unfortunately the teacher has entered wrong value. That is instead of 100, she has written 900. So that is the outlier. These kind of things will be cleaned by using this data preparation technique. Next one is data transformation, converting the data from one format to another format. Data conversion is nothing but converting from one format to another format. See, have you seen the data set? See here, the data sets are in the different ranges. Here, 85, 148, 183. Here, the next picture. This is the FEMA Indian Diabetes data set. This is another data set, FEMA Indian Diabetes data set. The data set ranges in the different values. Here, 80, 148, 85, 183, 89. Here, see, 72, 66. Here, 33. Some decimal values are there, right? So each and every feature having different range of values. So what we will do, we have to convert each and every feature in a specified range. For example, 0 to 1 or 0 to 10, whatever it is. So normalization is nothing but converting data from one format to another format. Means that data set having different ranges, we have to convert in a specified range. That is 0 to 1 or 0 to 10. That is the specified range. For that, we will use this data transformation. Next, feature selection. Feature selection. See, this is the input data set. We have, what is the purpose of feature selection is, if we have given the relevant feature for prediction, then the classifier will provide the highest accuracy. That's why we have to select the important features from the data set. See, this is the data set. From this data set, name is not the important. This name does not provide any information for the prediction, right? See, if anybody having the name Ram, then the Ram will study well. If it is like that, no. So this name does not provide any important information. That's why we have to remove the name attribute or features. So we have to select the important input features. What are all the important input features? Physics, maths, English, social. Based on this only, this machine learning algorithm will work, right? So if we have selected the important features, then the classifier or prediction model will provide the highest accuracy. For that, we will use correlation analysis, filter and wrapper methods. Correlation analysis means what? What is the relationship between physics and the problem solving? They will check each and every feature's relation. What is the relation between this feature and this feature? Like that, the correlation analysis will happen. Right? Next, learning system. This is the model construction. So what are all the important steps? Initially, we have defined the problem. Then we have prepared the problem. Then what is the third step? We have to learn, or we have to create a machine learning model, right? So totally how many types of machine learning algorithms are there? Totally 4 types of algorithms are there. Supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning. So when you see this input data, what type of learning will be good for this data set? When you see the output class label, then immediately you can say it is a supervised learning algorithm, right? So if a data set with input features and output features, then you can use the data set for supervised learning. Then what is the second rule? When you see the output class label, you have to check whether it is a continuous value or discrete value. So it is a what type of output? It is a discrete. So immediately you have to say the discrete supervised, that is binary classification. You can use this for binary supervised machine learning technique. So immediately you can select the supervised classification technique, right? Not regression. Regression is for continuous value. So if you see the data set, the machine learning expert immediately can identify this problem is suitable for which type of algorithm. So immediately you can say this is a supervised and classification problem. It is used for classification problem. Next, now we have to create the model, right? Machine learning model construction. First, you have to provide the input, right? This is the input. Name, physics, already name is cut down, right? We have cut down the name. Why? Because it does not have any important information for prediction. So we have cut down this name feature. So we have to include physics, maths, English, social. These 4 input features as well as this the output feature for training. So we have selected the supervised classification algorithm. Classification algorithm means artificial, maybe it is an artificial neural network or decision trees or SVM, support vector machine. This also can use for regression, but SVM, artificial neural network, will work will give good accuracy for binary classification, right? So when you see the input, you can identify the learning model. So now I have selected the supervised machine learning model. For training, I have given this input for training. So after training, it will create a model. So the model has been created, right? So I have given the input for training the supervised machine learning model. Now the model is, now I got the trained model. Now what is the 4th step? 4th step is evaluate. You have defined the problem. Second, you have prepared the problem. Third is you have developed the machine learning. That is, you have trained the machine learning algorithm using the input data set, right? Now you have to test the developed model. Already you have developed a model. That is, evaluate the model, right? See, you have given the data for training. Now the model is developed. Now what you will do, you will provide the input data set for test the model. Now you have given these input. Reena got physics 98, maths 90, English 76, social 73, right? So we need to know whether the model is properly trained or not, right? So we have to test the model using the data set without class label. We want to know whether the model is trained properly or not. How we can find whether the model is trained or not? Based on the output, right? See here, the output is initially it is given good. For second, it is low. It is correct only because the problem solving, when the problem solving capability will high, when the physics marks and maths marks will be greater than 90, then the problem solving capability will be high. If a student have the less than 90 marks, then the problem solving capability is low for a particular student, right? So this model got good accuracy. That is for two inputs, it gives 100% accuracy, right? So this is first. What is the first step? We have to define the problem. Then we have to prepare the data. Then we have to give the data for training, or we have to create a model. That is model construction. Next, we have to test the trained model. Already we have given the data to train the model, right? So these are all the important steps to develop a machine learning model. First, for defining a problem, only 4 steps. First, you have to identify the domain. You have to identify the objective from the problem. Then you have to collect the data. Then you have to write the description about each and every features and samples. Input features as well as output samples. For data pre-processing, you have to prepare the data for further processing. That is, you have to clean the data, clean the noisy or irregular or outlier data. Or next one is you have to transform data transformation, that is normalization. That is, you have to convert the different ranges into a specific range of data. That is data transformation. What is the third step? Third step is feature selection. Selecting the relevant feature. That is, remove the irrelevant features from the data set and select the important features from the data set for prediction. If the data set having important features, then the prediction accuracy will increase. That's why we have to select the important features from the data set. So we have developed and then we have tested. Next, model evaluation. How we can test the model using the accuracy of the developed model. Accuracy means what you will do, what you will say, for example, see, this is the actual output. Actual output means what? Actually, for this sample, good. For Joe got low problem solving capability, Shika got good problem solving capability, and Sam got low problem solving capability, right? This is the actual data. But my machine learning, this trained model will predict Ram has low problem solving capability, Joe low problem solving capability, Shika good problem solving capability, and Sam has got good problem solving capability, right? So this is the actual output. But my system has got predicted this kind of output. So what is true positive means? Always you have to keep this in mind. For binary classification, they will consider one is positive class, another one is negative class. Here, they have considered good as a positive class, low is a negative class. For 0 or 1 means 1 is positive class, 0 is a negative class. They will consider always. Keep this in mind. For binary classification, they will consider positive class as well as negative class, right? So in this predicted output, here, see, low instead of good, it is predicted low, right? That is negative class. See, I will show this. True negative. True negative means occurs when the model correctly predicts the negative class. Here, where is true negative? This is the true negative. Joe low, here also low. This is negative sample, correctly predicted as negative. So that is true negative. That is true negative is 1. Next, true positive. This is the true positive. Which one? Shika is true positive. Positive samples correctly classified as positive. That is true positive. See, true negative occurs when the model correctly predicts the negative class. That is, negative class is correctly predicted with negative, right? Then true positive occurs when the model correctly predicts the positive class. That is, good is predicted as good. That is true positive. Next, false negative occurs when the model incorrectly predicts negative class, right? Here, Actual is good, that is positive class, but it is predicted low, that is negative class, that is false negative, right? Here false negative is also 1. What is this? Actually positive, but it is predicted negative, that is false. Falsely it will predicted as negative, falsely predicted as negative, that is false negative. Next, false positive occurs when the model incorrectly predicts the positive class, but actual class is negative. See, here actual class is negative, but here falsely it is predicted as positive. That is what? False positive. Here, false positive. So what is true positive? True positive is Shika. Positive is predicted as positive. Truly predicted as positive. That is true positive. True negative means negative value is predicted as negative. That is true negative. Next, false positive. False negative. Third one is false negative. False negative is which one? Falsely, it is true positive classes identified as negative. These are all the true positive, true negative, false positive, and false negative. This is nothing but confusion matrix. When you have given the binary class classification, your prediction model will provide an output like this: true positive, false negative, true negative. So you know the difference between true positive, true negative, false positive, and false negative, right? Next, model evaluation. Model evaluation is nothing but model testing. First, see, this is the label data, past label data. Label data means we have given this is cat and this is dog to the model training. Model training means machine learning algorithm. We can select. This is binary class classification means we have to select the supervised classification algorithm for training this past label data. Then this is the trained model. We are providing the test data. This is the test data. We are providing the new data for the trained model. This model is trained machine learning model. Then it will provide the result as output, whether it is a dog or cat, right? So this is data. This is using this data. We are providing the data to model training. This is trained model. We are providing the test data to test the trained model. It will provide the predicted result, right? This is model evaluation. Next, the model is evaluated based on the performance metrics, that is accuracy. There are so many performance evaluation metrics are there. Here I have used only accuracy for this model evaluation. So accuracy equal to true positive. Already we have discussed. True positive is correctly predicted as positive. True negative means negative sample correctly classified as negative. Next, false negative means this one. Positive classes falsely predicted as negative. Next, false positive means negative classes falsely predicted as positive. So you know these values means you can calculate the accuracy of the developed model, right? This is the basics about model development, right? So what is the first point? First, you have to define the problem. For defining the problem, you must know the 4 questions. First, what is the domain of that problem? Then objective of the problem, you must know that. Next, where you have to collect the data collection, then data set description, each and every input features as well as output features, you must know that. Next is the data pre-processing, that is data preparation. Third is very, very important. Based on the data only, you have to select the model. Then the selected model is trained using the pre-processed data set. Next, what will happen? We are providing the data to the computer for learning from the data, right? Machine learning is nothing but learning from the data. Machine will learn from the data Now the model means what? The data is well trained by the model, right? The model trained using the data. Now the model is developed. Now we have to test the developed or trained model with the testing set, right? Then the trained model will provide the predicted result. This is the prediction result. So these are all the basic steps to develop a machine learning model, right? Next, see, this is the, if you want to know whether the model is trained well or not, you have to use the performance evaluation metrics, that is accuracy, mean square error, F1 score. There are so many metrics are available. Here I have used only accuracy as the performance evaluation matrix. Next, we will see one machine learning program. See, this is the machine learning program. I have used only a simple artificial neural network. So artificial neural network is a supervised machine learning technique, right? So I have taken this data set for training the artificial neural network model, right? Artificial. So this is a classification or regression problem. Students, only one question from your side. I need one answer from your side. This is the outcome is 1010. So it is a classification or regression problem. Am I audible? Students, it is a classification problem or a regression problem? Class label is 0 or 1. Classification, it is a discrete value, so it is a classification problem. If it is a regression, means the output class label is in the continuous values, right? Either 0 or 1 or 0 to 10, then it is a regression, but it is a classification, binary class, only either 0 or 1. So what is the first step? First, we have to define the problem. My problem is to identify whether a patient is having diabetes or not, right? So what is the first? First, we have to define the problem. For that, my problem is, I want to predict whether a patient is having diabetes or not. So I know the domain. So first, we have to know the domain of the problem. For define a problem, first domain. What is the domain of this problem? This is the medical domain problem, right? Next, objective. What is the objective and task? To predict whether a patient is having diabetes or not. Third point, data collection. Where I have to collect the data? From the domain. Domain is medical field, right? So I have to collect the data from the hospital or from the healthcare experts. Right, so this is the third point. Then I have to write the data set description. First, number of times pregnancies. This is the gestational diabetes mellitus. Gestational diabetes mellitus is nothing but during pregnancy, the woman is affected with diabetes. That is gestational diabetes. So I have to predict whether a pregnant woman is predicted with diabetes or not. If a pregnant woman is having diabetes, then that is a gestational diabetes, right? So first, number of times pregnancy. So I have to write the data set description. That is number of times pregnancies, glucose, blood pressure, skin fold thickness, insulin, body mass index, diabetes pedigree function, age. Then output is whether the patient is having diabetes or not. If a patient is having diabetes, then the output is 1. If a patient is having does not have diabetes, then it is a 0. So this is positive class label, this is negative class, right? We can assume 1 is a positive means it is a positive. If we are assuming 1 is a negative means based on the user. So it is a user defined, right? So either a patient is having diabetes or not, based on the class label only, we are going to predict. So I have written, initially I have saved this data set in the Google Drive. For that I have provided the link for that drive. Define the file path to the data set. Next, this is data set equal to pd.read_csv. To read the file, we have to use this libraries, right? In Python. This is a Python program. First, we have to import the libraries. So what is the purpose of Python programming? Why we are using Python? Python is easy to implement because it is having more number of libraries and inbuilt functions available, right? That's why we have choose this Python programming. So for that, initially we have to import the libraries. From the libraries only, I am going to develop or create a machine learning model, right? So this is the this line represents to read the head. What is mean by head? Head is nothing but it is displaying the features, input features as well as the output features. See, pregnancies, glucose, blood pressure, kidney, these are all the head. Explore the data set. Then X is for, always keep this in mind, X is for input features, Y is for output features. One more important point, before training the model, we have to split. PPT is not visible, ma'am. Okay.
Yes, ma'am.
I will
Not
share.
visible.
Wait a minute. See, this is the program to develop a simple artificial neural network model. First, you have to write the dataset description. What is the purpose of dataset description means? Here, define the features and target variable. Target variable is nothing but output variable, right? This is supervised machine learning technique. So we have to define the input features as well as output features. Before that, before creating model, you have to split the data set into training as well as testing. What is the purpose of splitting the data set into training and testing means? Training means, for example, totally you have 100 samples, right? For 80 samples for training and remaining 20 samples for testing. That 80 samples means 80 rows. You are providing the 80 rows, 80 patients details to the model for training. It will learn from that 80 samples. Now the model is learned. Next, what you will do, you will test whether the model is trained well or not. For that, you will use the test data set, right? See, here, X-train, they have used scalar bit transform. This is for training the data set. This is for testing the data set. They have used this features. Next, simple ANN model. So already you know artificial neural network is a supervised learning machine learning model. So we have to provide 8 input features. Totally see, I will show the how many input features? 1, 2, 3, 4, 5, 6, 7 and 8. So we have to provide 8 input neurons, hidden neurons. Initially you have to provide 8 because you can't give less than number of input features. So you have to provide minimum 8 hidden neurons with single hidden layer. Keep this in mind. Then ReLU. ReLU is the activation function for non-linear. If you are having complex connections, then you have to use ReLU. Sigmoid for binary. See, ReLU is in the hidden layer. Sigmoid is in the output layer. Why you have used the sigmoid in the output layer means your output is only binary class, right? That's why you have used
உங்களது mute
hidden
பண்ணி-
layer
mute
neuron
line
is
வருது. உங்களது
ReLU
mute
and
இல்லாம தான்
sigmoid
இருக்கு.
is in the output layer. Then they
அப்படியா?
have
அப்படியா?
given
mute symbol
Adam
காமிக்கல உங்களுக்கு.
optimizer. These are all the model constructions. If you have learned the artificial neural network only, you can run the, you can understand the concept. It is having input layer, hidden layer, and output layer, right? Then the loss is binary cross entropy. Why they have used? Because this is a binary class classification, right? Then metrics uses accuracy.
அதான் கேட்டேன்.
See
சரியா?
here, they totally epochs. Epochs means iteration. 10 iteration, validation is 0.2. Why they have said validation is nothing but testing, right? 80% for training and 20% for testing. So finally, see, this is the output of the program. These are all the, they have displayed 5 inputs. This is one sample, this is 2, 3, 4, 5. First 5 samples are they have displayed. Then these are all the iteration. Here they have given the loss, accuracy, valid loss, and valid accuracy. See, this is the, what is the difference between loss means, this is training. During training, how much error you will get. That is loss. This is accuracy. What is the accuracy during training? Next, this is validation means when testing the test set, how much error you got. During testing, how much accuracy you got. So when the iteration is increased, the accuracy also increased. See, initially the accuracy is 0.46, that is 46% to 59%. So your prediction model now is 59%. This is not suitable for medical prediction because 59 is not the good accuracy, right? So what you will do, you will change the parameters. You can't change the input parameters, but you can change the hidden layer parameters. That is, you can increase the number of hidden neurons. Like that, you have to again and again change the parameters and you will get the accuracy up to 99 point something you can get, right? So these are all the basic steps. This is the confusion matrix. Already we see true positive. See, 69 is true positive. This is true negative, false positive. This is true, sorry, this is true positive, true negative, false positive, and false negative. So based on this, you can calculate the accuracy. That is 69 samples are correctly classified as positive. 32 samples, that is negative samples are correctly classified as negative. Right? This is the confusion matrix. So these are all from my side. Students, if you have any doubt, students,
Ma'am, shall I conclude, ma'am?
yes, ma'am. That's all from my side, ma'am. Any doubt, students? For supervised, unsupervised, semi-supervised, reinforcement, training set, testing set, do you have any doubt? Okay.
Ma'am, shall I conclude, ma'am?
Yes, ma'am. Yes, ma'am. Shall I?
Okay, ma'am.
Thank you, ma'am, for your valuable webinar. No more duty is more urgent, no without pretending gratitude. Yes, it's time to deliver thanks. First of all, on behalf of DFY Club, I would thank our Chief Guest, Dr. Neha Milsey, PhD, for conducting this useful webinar to us. Next, I would like to thank our coordinator of this EFY class, Dr. M. Mohammed Alisa and Priyanka ma'am for conducting this webinar to us. Next, I would like to thank our HOD ma'am, Dr. S. Jayaravi, for providing this chance to attend this webinar. My dear brothers and sisters, thank you all for your kind and beautiful cooperation for this webinar. And applause, thank you all.
Shall I leave? Shall I leave, ma'am?
Thank you, ma'am.
Okay, okay. Thank you. Bye.